there wasn't enough AI today, so there will be a bit of AI-related presentation. And it will be about agent orchestration. So you all know probably the traditional approach where you have some chat model and you kind of give your query and you receive some response and then another query and another response. And that's nice, but it's kind of limited in some ways, right? Like that model needs to be kind of good at everything because you have just one. You cannot really have some specialized models for different tasks. And if you have just one model, it's kind of hard to verify that it's giving correct results. It tends to have hallucinations, right? That get sent over on the moon wasn't also quite what we expected, but so you need to verify, right? And if you want basically to scale and you have more and more traffic and more use cases, that it doesn't really scale well. So what can be basically a solution to this is instead of having like one LLM, one agent, to have a couple of them, right? Like some cluster. And then basically they can cooperate. They can work as a team. Like same as if you have one person that knows it all, it will not be very good. But if you have a team of people where everyone is some expert on something different, they can basically divide the work and cooperate, and everyone will do something slightly different, right? They can have different skills, they can have different tools. So that should give us much better results. If you have some task in the normal basically chat model, I can type something like, okay, give me this or that, and I can have this super huge prompt which will generate the whole code base. But it's useful. It's again kind of like an atomic task, right? It's useful if you can basically before break this task to like smaller pieces, like every task, and then those pieces can be actually solved by those different agents, different people. Meaning like agent which is good at generating images will take care of generating images. If I have some like easy task like writing just some summaries, I can use it to some cheap local agent which will not cost me money, right? It will not be some hosted OpenAI, whatnot. And so you can have specialized agents, and you can also avoid those hallucinations because you can have this like a verification workflow. Like you can have one LLM which generates some results, and then another one, completely different model, for example, can verify it and say, okay, maybe you have some factual inaccuracies there, or maybe you are missing some parts. And then it can basically take it back to the original model and say, okay, please fix this and that. And you can have this basically like a feedback loop. So those hallucinations will be severely limited. And also, if you are using like normal like chat model and you put something comes out, but it's essentially like a black box, right? Like what is it doing? Like how did actually achieve the result? Like what was it thinking? The reasoning behind? So it's kind of hard to tell. But if you have multiple agents, then you can capture the communication between them. Like one agent says, please, can you do this? This is the task. Then you get some response, and you can basically track all this communication between them, which makes it very transparent, and you can then easily debug what's wrong there. Also, the scaling is very good, and flexibility, because you can add more agents or remove agents, like even on the fly, right? Just kind of add them to the cluster, and it doesn't break your existing flow. So you can later basically extend your workflow to whatever you need later. And yeah, of course, it can be much cheaper because the AI can be kind of costly. Right now, it's heavily subsidized, so the prices are really something like 20% of what it should be, right? So it's usually better if you can, for example, solve easy tasks with some models just running locally on your machine, or some weaker models which are cheaper. Then it's better to do that. And you can do that with this part. Some parts can be strong, some parts can be weak. Okay, so you have like the teams of these people, and now they want to collaborate on something. But how do you do that, right? Like you have a team of people and you tell them, do something, build a house. But how do they do it? Like who is in charge? Like how this person in charge will coordinate? If the people are having conflicts while building, what will happen? If there will be some errors, what will happen? If some member of the team will die, how can we handle that, right? So the division of labor alone can be quite difficult if you don't have any basically anything on top of that. So to handle all those issues, you can have some framework which basically does this for you. So what I have here is basically like Autogen framework from Microsoft, which is written in Python, but the presentation is not about the framework itself. The message is about like breaking down your workflow into agent orchestration, right? Those frameworks, there are multiple of them. They are in different languages, so don't fixate on this particular framework, but more of about the idea. But this framework gives you those, it solves those problems which we had, like how to divide work, how to orchestrate it, how to handle errors, conflicts, and so on. And it can again integrate multiple different models and providers, so you can have like wide variety of LLMs. And so there are like a different way how this orchestration can work. Like those you need somehow tell the people how they should basically take turns and divide the work. So you can have something very naive like round robin, right? You basically ask each person in round like do this, do this, do this, and they kind of ask each other if somebody can solve the issue or pass it on. Or you can have some more complicated workflows where you have basically something who is responsible for selecting proper agents to work on specific pieces of functionality, right? So in this example, you can, for example, define some query like a LLM prompt, which will handle all the choosing of different agents. And it will say basically based on some criteria, like now this agent will take this part. When it's done, it can take the result and pass it to another agent, and you can define the whole query yourself. There are also some more complicated versions of this where you have some native support for like planning and breaking the task into in the very beginning like some subtasks, and then basically checking the progress and allocating those different tasks. Maybe some of them are running in parallel, some of them not. So this is an example of that. And if you have very strict because all of this is kind of fuzzy, right? It lets you like a LLM to decide who's next, but it can have hallucinations. It can be unpredictable, right? For the same query, you will not get same results every time. So if you need basically some strict workflow, like a state transitions, you can also have like really well-defined transition between different agents. So here only you start with agent 1, pass it to agent 2. If there is an issue, pass it back, and so on. So you have really strictly defined transitions. And now, hopefully, we will be able to, let me do one more thing. So in this demo, we have basically some task, and it's like to generate a presentation on some topic, right? Something like I need to go to Meetup, generate a presentation, and have a PowerPoint as the output. And just tell it, I want presentation about cool AI topics, whatever. And this basically group of agents should be responsible for generating this presentation for you. So you have some orchestrator who is basically responsible for dividing the work and asking individual team members to work on certain parts. Then you have researcher. So you get some topic in the beginning, right? Like tell me something how NanoBanana can generate images. And then the researcher starts and it takes basically gathering information across the different sources, and it will give you basically your data, which will be source of the presentation. And it will create like an outline of the presentation. And then there is a critic, which is completely different model, and it will give feedback to the researcher, right? It will say, maybe you have some inaccuracies, this is completely wrong, or this part is boring, or maybe you should put some cat images there, or jokes, or whatever. It gives some feedback, and it gives it back to researcher if needed. And this can be a cycle, right? So a researcher makes those changes, adjustments, then pass it back to critic, and so on. And once the critic is happy, it basically gives approval and says, okay, this is good presentation. And then there is like something which will, this markdown generator, which is agent, which can convert this whole unstructured data to like already structure the presentation in markdown. And this is already like all the slides, what should be in each slide, so the bullet points, even like a speaker notes, which should be there in the speaker notes section. And this presentation generator, it can take this markdown and generate PowerPoint from it, right? It can take some template, add some colors, fonts, whatnot, and it will generate your PowerPoint file. So this is the flow. There is this repository which I can share later, but to see it in action, essentially in this project there is very little code. Most of the stuff is just prompt definitions for individual agents. Like you are a researcher, your job is to research the topic and give output in this format, and so on. And or you are a markdown generator, or this PowerPoint agent actually has access to external program which can generate this. Are you familiar with MCP? Anyone? Yeah. So it's also very powerful that it's like protocol where you can connect LLM to different other sources, right? So it can connect to disk or database or GitHub and gather some information there. And it doesn't need to be part of the model itself. It can be basically like real-time data, right? So for example, even this markdown generator, or those agents, for example, are also calling like Python functions on that machine, and also calling those executables, which are for generating the presentation. But it could connect all to all those different basically data sources. It can search the web, basically anything. Yeah, so most of the definitions are, or the code is basically, there is just like 10 lines of code or something. There is basically prompts, that's it. And let me try to run it. So we have basically a topic for presentation, and that is whether Hawaiian pizza is good or bad, whether it's real pizza or whether it's like why everyone hates it, right? Do you like Hawaii pizza? No? Nobody? You do? Yeah. I think it's just like kind of passion to hate Hawaiian pizza, but it's really not that bad. Let's try what they will tell us. So when we run it, the first will act the orchestrator, and they will basically assemble some plan how to break it down to individual tasks, right? So we have like topic coming from user is Hawaii real pizza. And now basically the primary, which is the orchestrator, received action, and it says, okay, we will create a presentation on this topic, and there are like individual steps which we need to take, right? It will exactly break it down to like, I don't know, 7 different steps. Oops, yeah. And then you have basically like a list of tasks which need to be done, and it can basically distribute those tasks to those individual agents. It was having a lot of issues because there is like this safe word, like a termination word, that if any agent says like safe word, then it will terminate, right? So there is not like a infinite cycle where they are trying to achieve the goal. So there is like safe word terminate, and here in this task list as a last step, it was always saying, and when I say terminate, the whole process will end, and it suddenly ended, right? It never kind of continued to the next step. So it took a lot of tweaking to let him handle this. But essentially, he got this plan, and then he said, okay, researcher will gather information. Then the researcher says, it gathers all the information and says, okay, there are some key points, there are some assumptions, there is some suggested slide outline, and some notes which should be there for the speaker, and that's it. That's your presentation. And now there is this critic, and yeah, they are very polite between each other. So it's always like, thank you, sir, for getting your input. I will carefully look at it. And when it ends, it happened to me that for 5 minutes they were just thanking to each other for good work without terminating. But now it's a bit more tweaked. So yeah, the critic says, okay, there are some hints which you can basically take into consideration, some feedback, right? So on slide 1, do this, slide 2, do this. And overall, it's very nice, and I'm very polite again, but please make those changes. Again, there is the researcher. It says, okay, there is like a changed version of my presentation. Critic says, okay, well executed, great balance, humorous title. Okay, and it says approve. So now basically the cycle is over, and it can continue to the generating the actual presentation. And this markdown generator says, okay, I will take all this unstructured text, and I will basically create markdown for that, which is already like one-to-one the presentation. Representation of the slides. So it's like some, metadata, title, those individual headings are just like, slides and slide sections. So is everyone familiar with Markdown? Yeah. So that's nothing new, just Markdown. Here you can see it also generated like speaker notes, that part which only speaker can see. All right. And now there is this presentation generator, which is the last one, which actually generates the PowerPoint. And you can see that it's doing some functional call. So it's actually calling some Python function to be executed. And as part of that, it's actually generating the markdown. And it says, okay, I have some result. I generated a presentation. It's generated here in this file. And the primary one says, okay, we achieved the goal. The file is generated. We terminate it. And now you have some detailed logging what happened during the session. And I don't know why I can't. There is this, just a second, just to show you the presentation. It's having weird behavior. All right, so let's see. Okay, so it generated this presentation with already some styling, and you can see that, yeah, some facts about pineapple pizza and basically all the presentation is generated by this set of agents, and it's much more basically better results than you would have when using just one agent, because you wouldn't have this feedback loop, and you couldn't break this down into like individual parts, right? Okay, so oops. Yeah, so if you're interested, here is basically, yeah, and there is also one thing which is called Autogen Studio. So without any coding, you can just do the whole thing like in UI. You can basically create definitions of all those agents, tell them what they each are responsible for, even if they can use any tools like search the web or access the database or whatever. And this can either basically generate JSON, which can be used by this framework, or you can just run it in this web UI straight away. So this is good if you are not friendly with Python and just want to try some workflow like this. Okay, thanks for watching. Do you have any questions? I haven't worked with that, but